Okay, so this is the International A-Level fp3 June 2016 question 8. This is a reduction formula question, okay, and it's a tricky one at that. So how do we start? First of all, some of the reduction formula, a lot of it is practice, but they do give us a slight hint, which is this right here, okay? So having that in mind, we're going to rewrite our integral in a way which will let us have that. So I'm going to rewrite that now. In equals ln2 0 tanh 2n. How am I going to write it 2n minus 1 like this? However, it still needs to be tanh 2n. Therefore, I have to multiply by tanh squared, for the x, tanh squared x dx. Alright, so what's the next step? We want to have, so usually when it comes to reduction formula, lots of people go straight into integration by parts. That is usually a very feasible option. However, for this one, it isn't, and you kind of need to think of a way to isolate this tanh 2n minus 1, and that way would be to create this into a different identity. Okay, so that will be the set identity. Yeah, that will be the set identity, and that one is 1 minus sec. Oh no, sorry. 1 minus tanh squared x is equal to sec squared x. That can be derived from the formula booklet. I won't go into that detail right now. I can in later videos if you guys want me to. I can do that, but I'm just not going to do that now. So therefore, this gives us that tanh squared x is equal to 1 minus sec squared x. All right, I've done that in green just so it's formula. Right, so let's plug this in. Make sure it's neat, make it easy for your examiners. Okay, tanh 2, n minus 1 x multiplied by 1 minus sec squared x dx. So we can expand this. So I'm going to expand this quickly, just so you see it. I don't want to jump into any. I'll make sure it's very easy to see. Sorry if it's a bit messy for the first time. Tanh 2 n minus 1. I think I'd write it as 2n minus 2 for this one, just because I'm not going to be turning it into a. I'm not going to be turning it into this, right? So, sorry, I haven't really explained that. A good thing to do is to see, okay, what would in minus 1? This is when you want to spot, because you kind of do need to force it in there. So a good thing to do is to see when in minus 1, what that would look like. So I'm going to write that in green here, sorry. In minus 1 would look like, still having these limits, you can still have the limits, tanh 2 n minus 1, okay? Just so we have that, and I'm going to just to keep it kind of neat and organized, you follow the same steps. I'm just going to write this all down here. That equals tanh 2n minus 2. Right. Because now we have this. If it was multiplying, we wouldn't. But we can split this into two different integrals because we're not multiplying. So this can be split. So let's write this down again. Sorry, guys. Sorry about that. This ln2 0 tanh 2 n minus 1 dx. Let's close that. I always forget the x's when it comes to this one. I'm sorry about that. So that bothers you as well. Hopefully it doesn't. And then tanh 2n minus 2 sec squared x dx. Okay, so immediately from what we've done before, you know, with the green stuff, this stuff here, this looks the same. Therefore, we can plug in I minus 1. So that's the first sort of step done. So just keep that in mind here. But we're going to be working with this one. So what we can tell is that this integral here, so oh my god, sorry, this this integral here is going to have to look like this, right? Okay. So let's work towards that. First, so you might be thinking to yourself, how are we going to integrate this? So that's a very ugly square. How are we going to integrate this? Well, it's actually not that bad. So, what you have to spot, and they do give you some hints. I'll show you the hints. The hints that they give you is that 2n minus 1 and to the power of 2n minus 1. But what you have to spot essentially is the reverse chain rule. Okay? So, what here? Like, well, you hopefully know what the reverse chain rule is, but what here looks like a differentiate into the other thing. And just look at the formula booklet. Obviously, it can be different with the hyperbolic sometimes, but looking at the formula booklet, we can tell, or we can see that when you differentiate tan x, you get sec squared x. Okay, that transfers over to hyperbolics. It doesn't always, so do check that. You can memorize that. They have it in the book, but that does transfer over. So we're going to see what we can do with that. So I think you should take away 1. So I'm just gonna test it out. This is how reverse chain rule usually works. I'm gonna say, okay, so what if I did tanh 2n minus 1? Because obviously when you're integrating, because okay, so the way this works is when you integrate, you could differentiate back into it. So we're gonna differentiate this and see where we get. What occurs, okay? Let's differentiate this. 2n minus 1. What's the different, like, what happens when you differentiate tanh? You get sec squared x, so we'll do that. Sec squared x, and you obviously take away 1 from the exponent of tanh, so you get tanh 2n minus 1. Okay, looks similar. However, we have a 2n minus 1. What can we do to fix this? And they do give us a really big hint here, and that's that. That's this thing right here. So you can just divide it by 2n minus 1. So if we were to divide our original one, which was the tanh 2n minus 1, we'd get 1 over 2n minus 1 tanh 2n. Oh, I keep forgetting the x. This is bad. I'm sorry. I should not be forgetting the x. You get 1 over 2n minus 1 tanh squared 2n minus 1, which is correct. However, we've still got limits. So we have to put these limits in. And that would be ln2 and 0. Okay, so we can put these limits in now. Oh, sorry, I'm making it a bit messy, sorry about that. How do we do these limits? Well, we can see that the 2n minus 1 is out, so we can just focus on the tanh. And for that, we have our trusted calculator. So if you want to access hyperbolics, I don't know if anyone ever knows about this, you press options, you go to hyperbolic functions, and for tanh, you press 3. Tanh 0 is equal to 0. Tanh natural log 2 is equal to 3 over 5. So we could just write this as 1, 2n minus 1, brackets 3 over 5 to the power of 2n minus 1. Great, we've got both sides. Let's plug this all right back in. So we're going to get in is equal to in minus 1, which was this here, minus the integral with the limits, natural log 2 and 0 of tanh 2n minus 2 sec squared dx. What's that? We found that here. We've proved it because we already knew it was going to be. And that is equal to 3 over 5 2n minus 1. So yeah, these questions can be very tricky, and they can kind of feel like you don't know where to go. I always recommend looking a bit ahead. Don't jump straight into the question. So I think it's always better to just kind of look at the answer they get and try to base your working around that and trying to work towards that as well. Don't be scared to start one, and if you see it's going bad, just restart. Don't be scared to do that. But anyway, now we're going to do part B. Part B is usually much easier, and you can always get the marks for part B without having done part A. So let's just do that here. Okay, tangent to the power 4x dx with the same limits. Okay, what are we going to do? So we know tangent to the power 4x is going to be tangent to n. Well, we can relate them back. We just know that n needs to equal to 2. So really what we're looking for is I2. Okay, if we're going to solve I2, we plug that in. We get I1 minus 1 over 4 minus 1, which is 3. 3 over 5. 2n minus 1. But I mean 4 minus 1, that's also 3. Okay, so we've got one part. However, we need to solve for I1. I1, what would that give us? And, always important to look at that, this works for when n is greater or equal to 1. So this is going to be the last time we can use this reduction formula for this specific one. That's going to give us I to the power 0 minus 1 over 2 minus 1, 3 over 5, 2 minus 1, which is just 1. I to the power 0, it's not as simple as just using the reduction formula. Okay, we do need to solve this because look, the reduction formula only works when n is greater or equal to 1. So I equals 0, we just need to integrate ourselves. Right. However, we've got our equation in the beginning, this one right here. So let's plug in I equals 0. I equals 0 is going to be equal to ln to 0 tangent to the power of 0, and we know that anything to the power of 0 is equal to 1. So that's just going to be 1 dx. Differentiate that, we get x with the limits ln to 0, which is just equal to ln 2. Right. So let's just plug everything in. I2 is equal to I1, which is equal to I0, which is ln 2, minus 3 over 5, minus, that's the I1 part, minus 1 over 3, 3 over 5 to the power of 3. Let's plug this all in now. I to the power 2 is equal to ln 2 minus, I'm just going to put this in my calculator, you can do this as well. Don't forget the negative symbols. 3 over 5 to the power of 3, which is equal to 84 over 125, which is correct, and therefore we get 4 marks. So that was my explanation of reduction formula. This is it's a tricky chapter, not chapter, sub-chapter. The questions can be quite challenging, and the algebra in itself is not too hard, it's just spotting which one you have to do. So a lot of it does take practice. I'll be doing any FP2, FP3 questions, so if you have any inquiries, just tell me in the comments or send me a message, I don't know how it works. And I'll do that question. I'll probably be doing some more reduction ones, as I'd say a lot of issues do arise from that. Maybe vectors are hard, and coordinate systems. But apart from that, FP3 isn't too bad. So thank you for watching, and I'll see you in the next one.